Triangle. A polygon have 3 sides, or the least number of sides is called a triangle. The 3 line segments forming a triangle are called sides of a triangle. The points of the triangle A, B and C are called vertices of triangle ABC. The triangle has 3 angles at its vertices, made by 2 successive sides.
Classification of triangles. Triangles can be classified according to the measures of their sides as well as according to the measures of their angles. A triangle having all 3 equal sides is called an equilateral triangle. A triangle having all 3 unequal sides is called a scalene triangle. A triangle having 2 equal sides is called isosceles triangle. Based on the measure of angle, a triangle is acute angled triangle when each of its angles is acute or less than 90 degree. In a triangle, if any one angle is a right angle, that is 90 degree, then the triangle is called right angled triangle. If any one angle of a triangle is an obtuse angle, that is more than 90 degree, it is called an obtuse angled triangle. Congruence of triangles. Here are 2 triangles, namely triangle ABC and triangle PQR. If you trace triangle ABC and place the tracing on the other triangle PQR, you will find that the triangles are identical and they cover each other exactly. 2 triangles are congruent if they are copies of each other, and when superposed, they cover each other exactly. In other words, triangle ABC is congruent to triangle PQR if and only if A falls on P, B falls on Q, C falls on R, AB falls on PQ, BC falls on QR, and AC falls on PR. Criteria for congruence of triangles. With one of the following 4 criteria, we can prove that the given 2 triangles are congruent. Criterion 1. SSS congruence. All the 3 pairs of sides are equal. 2 triangles ABC and QRP are congruent if all 3 pairs of sides are equal. In triangles ABC and QPR, AB equal to QR, BC equal to PR and AC equal to PQ. Examine whether the 2 triangles are congruent or not. Here, AB equal to QR, BC equal to RP, AC equal to QP. Since 3 pairs of sides are equal by SSS congruence criteria, the 2 triangles ABC and QRP are congruent. As seen here, it can be said that A coincides with Q, B coincides with R, and C coincides with P. So, we have triangle ABC congruent with triangle QRP. The order of the letters in the names of congruent triangles displays the corresponding relationships. Thus, when you write triangle ABC congruent to triangle QRP, you mean that A lies on Q, B on R, C on P, AB along QR, BC along RP, and AC along QP. Criterion 2. RHS congruence. Right angle, hypotenuse, and a side are equal. 2 right-angled triangles are congruent if the hypotenuse and one side of one triangle are respectively equal to the hypotenuse and one side of the other triangle, that is, in 2 right-angled triangles, that is, triangle ABC is congruent to triangle PQR. Criterion 3. SAS congruence. 2 pairs of corresponding sides are equal and the angles between the pairs of sides are equal, then triangle CAB is congruent to triangle FDE. Criteria 4. AAS congruence. 2 pairs of corresponding angles are equal and the sides included in the pairs of corresponding angles are equal. Triangle ABC is congruent with triangle PQR. Exterior angles of a triangle. Consider a triangle ABC. The side BC is produced to P. The angle ACP formed lies outside the triangle ABC. This angle is therefore called an exterior angle. ACP of triangle ABC. There can be three exterior angles of a triangle. Angle ABC and angle BAC are called the interior opposite angles or remote interior angles of angle ACP. Angle ACP equal to angle ABC plus angle BAC. Medians of a triangle. Consider a triangle ABC. Let AD be a line segment drawn from the vertex A to the midpoint D of the opposite side. The line segment AD is called the median from A to BC. A median connects a vertex of a triangle to the midpoint of the opposite side. A triangle has three medians. Centroid of a triangle. The three medians of a triangle meet at a point, which means the three medians are concurrent. The point of concurrence of the three medians of a triangle is called the centroid of the triangle. Here, G is the centroid of triangle ABC. Altitude of a triangle. Observe the following triangle. From A to BC, we can draw many line segments, but among them, AL is the shortest. Here, AL is perpendicular to BC. The length of this shortest line segment coming from the vertex A to the side BC gives the height or altitude of triangle ABC. Pythagoras Theorem. A right-angled triangle is one which has one right angle and two acute angles. The side opposite to the right angle is called the hypotenuse. The other two sides are called the legs. Pythagoras, a Greek philosopher, found a very important and useful property of right-angled triangles. Pythagoras Theorem. In a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. In a right-angled triangle, the sides which contain the right angle are usually referred to as the base and perpendicular. In the figure shown here, triangle PQR is right-angled at R, so that PQ is the hypotenuse and PR and QR are the sides of the right angle. Then PQ whole square equal to QR whole square plus RP whole square, or hypotenuse square equal to base square plus perpendicular square. In a right-angled triangle, the hypotenuse is the longest side. An important derivation of Pythagoras theorem. Here is an important derivation of Pythagoras property, which is stated as follows. Of all the line segments that can be drawn to a given line from a point not lying on it, the perpendicular line segment is the shortest.